Hello everyone, my name is Nael, I'm a computational journalist and the creator of Code Like a Journalist, a free online open source course about data analysis and data visualization. Today, in this tutorial, we are going to code a project. We are going to build a stock market simulator. We are going to fetch historical stock market data and use it to estimate how much we would have gained or lost by investing in publicly traded company. Before you start, make sure that you have completed the first steps and the pushing further sections. This project is really about practicing everything we've learned so far in the previous lessons. If you want to know when new lessons are available, subscribe to the newsletter, add a star to the GitHub repository, subscribe to this YouTube channel. So I'm a journalist. I like to start projects with a crystal clear question. And today our question is, how much would we have gained or lost by investing in a given publicly traded company on a specific date? To answer this question, we will need to calculate the difference between the initial amount invested and the final amount after a few years. There's also three variables that we can identify that will impact the results. The company that we're going to choose, of course, the initial amount of money, and the date of the investment. So these three are probably good candidates to be put into variables at the beginning of our script. Let's start. I have VS Code open over here. We can open and start a new project. Here we go. Let's create a main.ts file and a dino.json file. We need to search for data first. For our simulator to work, we need historical stock prices, and one of the most common sources is Yahoo Finance. When you are using small amount of data for educational purposes, the use of the data is tolerated. If you want to use large volumes of data for a commercial project, you need to reach out to the team behind the site and probably to purchase a premium subscription. So let's go on the Yahoo Finance website. So it looks like this. And you have a search bar over there, and you can look for publicly traded companies. So for example, we can search for Apple. Here's Apple. And here's the stock price for Apple. On the side here, you have a historical data tab. You can click on it, and you can see that you have the stock prices. You have the date, and what we are really interested in is the adjusted closing price, right? So for a given date, how much an Apple stock is worth. Now, this is nice, but this is a table on this web page. We would like to be able to retrieve this data, and we want all of the data. Here we have a date picker. We can pick max if we want, days, month, etc. So how can we retrieve this data? So the data doesn't come from nowhere. Usually websites like this one, they use APIs. APIs can be pinged. You can do a request to an API, basically with a URL. And the API looks at your URL, so you can say, hey, I want Apple stock prices, and the API will search for it and send you the data back. It's usually how we do websites like this one, because it's easy to refresh the data in an API. It's more difficult, more costly, it's slower to rebuild the website with new fresh data. So Yahoo Finance, for example, there's a lot of things here that do not depend on data. So all of this part here, this part over there. So you can build a shell for your website. And then you can have components that we will load just depending on the data that will be received from the API. And you can see that, right? So if I ask for 1 year of data, you can see that there's a loading state. This table doesn't show up right away, right? First it loads and then it renders. This means there's probably an API request behind it. To look for the API request, you can check in View, Developer, and Developer Tools. I'm using Chrome, but if you are using something else like Firefox or Safari, you can do the same thing. You can check the source code of any pages. Now, where you want to go in there is to the Network tab. And maybe this sidebar here is down below. If you want to switch the position, you can switch it with these options over there. So in the Network tab, if you refresh the page, you'll see all kind of things appearing over there. These are all of the requests made by the page to load all kind of things, images, fonts, and of course data. So we can try to play with this, with the page, interact with it to see where does the data comes from. So if we click on the date picker and we select maybe 3 months, oh, you can see that there's a new request over there. It's a fetch request. We know what fetch means, right? We did the fetch data lesson. And it starts with AAPL, which is the stock market symbol for Apple. Very interesting. If we want to see what's in this request, we can do a right click, open in a new tab, and it looks like JSON data. You can see that we have, well, this is maybe very small for you. You can see that we have curly brackets, quotes. It looks like an object. Here it looks like an array. It looks like we have data in there for Apple. Now, maybe we can try this one more time with the maximum duration. So Apple was started being publicly traded in December 1980. Let's see. When we clicked on here, there's a new request that has been made. And if we click on it again, if we do a right click again to see what's in there, we have a lot of data in there. This is a very long JSON file. This looks very promising. If we have a closer look at the URL, so this is maybe a little bit small for you. It's the same thing as this here. If we look at the URL, you can see that it's a URL with a few parameters. So for example, you can see that we have period 1, a timestamp, period 2, and a timestamp, symbol, AAPL. We have lang parameter and a region. I'm in Canada, so it has detected me in Canada. So this looks great. Apparently, when you request this URL, you get Apple stock prices. We can explore this more with code. So in our main file, we can fetch this data, right? You can copy the URL. We've done this already. You know how to do this, right? We did the lesson about it. Await fetch. We can paste the URL and we can parse the response as JSON, because when we looked at it, we had curly brackets, we had square brackets. It really looked like a JSON file. And we can do log data. here we can run the code by doing dino run a. So we have the authorization to fetch data, watch, check, and main. Here we go. And now we have data in our terminal. And if we have a better look here, because the object is prettified, we have the indentation. And if we have a closer look at what's in there, you can see that we have the currency, the symbol, we have a lot of metadata information, and then we have timestamps. This is an array. And inside the indicators, we have the adjusted close price, which is what we're looking for. The timestamp is inside an array, the timestamps, and the closing prices are inside an array as well. This looks very promising. We also have all of the, it looks like we have a lot of elements. Is this enough elements? Yeah, I think so. 11,000, looks like we have everything in there. So let's try to get the timestamps and the closing prices. So first, timestamps. You might not be familiar with this. Timestamps usually are the number of seconds or milliseconds since January 1st, 1970. This is how durations and dates are usually represented in code. And this looks like timestamps in seconds. So let's try to go through the object to retrieve the timestamps. So we can do something like this, timestamps. Let's create a new variable. And in the data, if we have a look, so this is our data, you see that we have a first object chart. So let's go inside chart. Inside chart, we have another key result. And result is an array. You can see this with the square bracket. So inside the array, what we want, it's an array with just one object. So we want the first object. So now we are in there. And in this, we want the timestamp. So dot timestamp key. So now if we log this, you see that, yeah, these are our timestamps. We have retrieved the timestamps. Nice. We can do the same thing for the adjusted closing prices. So again, we can call this values. Data. So we need inside chart. Then we go to result. Result is an array with just one object, as we saw. But this time we don't want to go to timestamps. We want to go to indicators. This is where the closing prices are. Indicators. This is an object, and there's a key add close, like this. And this should be what we're looking for. So let's see. I'm going to comment the two other logs. Okay, so these are our values. You can see that it's an array, there's an object, and then there's a key, and then there's the actual values that we want. So we can adjust our code. We want the first object of this array, and in this object, we want this key. And so now we have our values. Great. So with this code, we are now able to have first our timestamps. By default, Dino logs just the first 100 items in an array. We have 100 items there, plus 11,033, and the values 100 values, and then 11,033 more items. These are timestamps. These are our closing prices. And this is looking very good because we have two arrays with exactly the same number of items. This probably means that the first timestamp should be matched with the first value here, the first closing price. The second with the second one. Looks like they're supposed to match together. What we can do to be sure is to check the first and last items and to log them. And we can compare that with the results on Yahoo Finance website. So for the first timestamp, it's quite easy. We can do first timestamp. It's a timestamp in seconds. We can create a new date, except that timestamps in JavaScript and TypeScript are in milliseconds. So we can just grab the first value and multiply it by 1000 just to convert it properly. Here we go. We can do the same thing with the last timestamp. To retrieve the last timestamp, we grab the array. We look for the number of items in the array, -1. So this will be the last index because indexes start at 0. We'll multiply it by 1000 because we want it in milliseconds, and right now timestamps, it looks like they are in seconds. And we can do the same thing for the first value. So it's values index 0, last value, it will be values at length -1. And so now we can log all of this. First timestamp, last timestamp, first value, and last value. Let's see. All right. So I have different values compared to the lesson because I'm doing this a few days later. But you can see that the first timestamp is December 12, 1980, which is when Apple was started being publicly traded. So that works. You can see that the first value is 0.09. So that was the starting stock price for Apple. And if you check on Apple's website, you'll see that this is right. That was the selling price at the time. The last timestamp is today. And the last value, 235. We can double check that by going back to the website. And you can see that if we click on summary, might be a little bit long. You can see that the current price is 235. And this is what we have. So we were right. This is the stock price data that comes from Yahoo Finance API to feed the website. And we can fetch it and retrieve it. By the way, this technique, checking the network tab and seeing the requests, this is a technique called web scraping. We'll have a full lesson about it later on. It's very useful when you work as a journalist and you need to retrieve some data. Of course, you need to be careful. You don't want to send too many requests to the servers. You want to be respectful and you don't want to break the law. All right, so this is looking pretty good. Now, something that we could do to make this a little bit better is to extract some of the URL parameters. So for example, we will want our simulator to work with different companies, not just Apple. So we could extract the company symbol. Here you can see that we have the company symbol twice in the URL. So we can use backticks now. There we go. And instead of having it hard-coded in the URL, we can inject it with a variable. Nice. Like this. So now if I change this for another company, it will be updated in the URL. Another thing that we could do is the periods here. So this is hard-coded, and this will return value specifically for the company that has been selected on the website. But in our case, we want something more general than this. Period 1 here could be extracted as well. And period 1, the timestamp could be 0 in our case. We just want as much data as possible. 0 in this context, a timestamp of 0 is January 1st, 1970, which is more than enough for us. And the second period in our context is always the latest available data. So we can use date now, which returns the number of milliseconds elapsed since January 1st, 1970. And this here will always be the number of milliseconds when you run the code, and we can inject it in there. Here we go. And so now we have a more general URL. Let's save this and see if the results are still correct. So this still works. You can see that we still have the right values, which means that the API from Yahoo is accepting our more general parameters, which is wonderful. We will be able to use this with different companies. Let's talk about caching. So right now, every time we save main.ts, the code is being rerun and we are fetching the data again, We are hitting Yahoo servers with our requests. It's fine because we are not saving the file too often, but still, we could improve this. Instead of fetching the servers every time, we could write the data on our computer and use the local data instead of fetching it every time. That would be a little bit more respectful. We don't need the absolutely latest data every time, and we don't want to be blacklisted and blocked forever by Yahoo Finance. So we can cache the data. To check, the logic here will be to write the data to our computer. And basically the script, our code, will check, hey, is there a file for this company that is already in cache? Yes, use it. Don't fetch the data. No, there's no files for this company. Maybe it's the first time that we are running the script with a new company, like Amazon, for example. There's no local file with the data in cache. Oh, then fetch it. And this is what we're going to do. To check if a file exists, we are going to use a function called exists from the standard library, the FS module. FS means file system. So the first thing that you need to do is to stop your terminal, and you can install, okay, I'll do it with you, dino add gsr at std for standard FS. This will add the file system module from the standard library to our project. If you check in dino.json now, you see that it has been installed. And now we can import it at the top. Import exists from, here it will suggest it to us. So this function here will help us check if there's already data in cache or not. We need to decide where to cache the data. So we can create a new folder and we can just call it data. Now, we are going to create a JSON file to cache the data. We need a path for this file to decide where are we going to write it, what will be the name of the file. We can create a new variable, path, and we can use backticks. Oops. We are going to put it inside the data folder that we just created, and the name of the file could be the name of the symbol of the company, .json. So this here will create, this is a path with aapl.json. But if we decide to test the script with a different company, for Amazon, for example, then the path will be, I guess, amzn, if we switch this to amzn. Cool. So now we can create a let data variable. So this is where we're going to put the data. It's a let variable because we don't know yet if we are going to read data from a local file or fetch new data. And we can start, right now it's red because we have data in there. Maybe we can comment all of this for now. Here we go. So the first thing that we want to check is exist path. So exist is async, we need to use await, and we're saying, hey, check if this file here exists or not. If it doesn't, if the file exists, we can log a message, console log, retrieving data from the cache. And we can actually retrieve the data. So now data that we created here will be populated with the local data. And we can read the local data with dino read text file. So this here is the path to the file. We check if the file exists. So in this case, the file is in data aapl. If it exists, great. It means that we have data in cache. We log this message saying, hey, I'm retrieving data from the cache. And we are reading the data. And since this is a text file read, we need to parse the JSON. So instead of having just a string, it will be parsed and it will come back as this object with the arrays and everything that we've seen before. So now data here will be populated with the data from the cache. If the file does not exist, it means that we need to fetch it. And so in this case, we can use console. We are going to log, hey, I'm fetching data. And we can reuse the code that we had below. So we have the response, we have the data, that is the response being parsed as a JSON, except that here we cannot reassign data. It's the data that we created just above the conditions. So now if this is false, the file doesn't exist, we actually fetch the data. And there's one extra step. We want to cache it. We want to write the data to the path. And now the data will be cached. So we are reusing the path. The file does not exist, right? So this here is false. This won't be executed. We go there instead. We fetch the data, we parse it, and now data is populated with the data that is fetched. But before proceeding with the rest, let's cache the data that we have so far. Let's write it on our computer. So next time, if I'm rerunning this code, then the file will exist and I will be retrieving it from the cache. That's the logic. Here we are stringifying the data to write it. And now, if we can grab our values and our timestamps again. Here we go. And we don't need the rest. So let's save this and let's run our code again with run-a watch check main.js. So this is the first time that it's the first time that the code is being run. You can see that we have a fetching data message because data was empty. But when it fetched the data, it also saved it. So now we have aapl.json, and in there we have the data that is cached. If we save again with Command S or Control S if you are on a PC, if we save again, whoa, you can see that now the message is different, retrieving data from the cache. Because now, when the code is running, this is true. The file now exists. So instead of fetching it again, we can just retrieve it from data. It works. We are using cached data. If we want to test this, we can change the symbol for Google, for example. And if we save, oh, you see, it's the first time that we are using this symbol here. So the file here does not exist yet. We fetched the data. And you can see that the data for Google has been cached. If we save again, now we are retrieving data for Google from the cache. And if we switch back for Apple, well, there's still the Apple data, so we are retrieving data from the cache again. So this is a nice little technique to cache data, and it works pretty well. Here we are using a cache just to avoid hitting Yahoo servers too many times, but very often in like real life projects, the cache is also used to speed up, to make your code run faster, because fetching data over the internet is quite slow compared to reading data from your computer. And also sometimes you can cache the results of really heavy and long computations, so you don't have to run the same computations again and again. You can just use the result directly. So we have our data, it's cached, which is wonderful. We can work in peace without worrying about Yahoo Finance servers. Now let's clean our data. Something that we can do first is to refactor, to clean up our code a little bit. Main is becoming quite long. It will be easier to have some functions to organize our code. So we can create a new folder and we can call that helpers. And in helpers, we can create a function called getData.ts. And this here will be exported, get data, and we can move everything that we have in there, except maybe the symbol. We can move all of this now inside get data. So we have a few errors. So for example, here get data, export default function, get data. So we have a few errors. A symbol here does not exist in this context. So we can pass it as a parameter and it will be a string. Await exists. We are not importing exists in this file. So we need to bring it as well. There we go. We have an await here, but await is just for async function. So we need to create an async function instead of a sync function. And finally, timestamps and values are being created, but they are not being used. What we want to do is to return them. And finally, in main, what we want to do is to import getData. Import getData. So VS Code is quite clever. It knows that this is what we want to do. And so now we can use getData in main. So await getData. GetData expects the symbol. Here we go. And we have, if we check the signature, you can see that it's returning a promise with timestamps and values. We want to retrieve them. And we can do that this way. I think it's the first time that I'm showing you this syntax. Basically, when you have a function that is returning an object, like this, this is the shortcut to create an object with variables, right? So timestamp is a variable, it will become a key, and the values inside the timestamps variable will become the values of the key. Same thing with values. We can do the opposite in there. We can destructure the object. So if you can do this kind of syntax to create variables directly from an object. GetData here is returning an object with a timestamps key, so we can automatically create a timestamps variable with the timestamps values in it. Same thing for values. So if I log this, I'm going to see my timestamps. And if I log this, I'm going to see my values. So this is called destructuring. It's a nice little trick to write code that is a little bit shorter. So our code now is better organized. Main is clearer. We have a clear idea of what this is doing, and the getData code is stored in one file, which makes it more manageable. We can check our timestamps one more time. So our timestamps here are seconds, but it's not very convenient to work with this, right? It would be way better to have them as dates. Let's convert them to dates. To do that, let's create a new helper function, and let's call it clean timestamps.ts. We are going to export a default function clean time stamps. Here we go. And this function will expect the timestamps, right? So we can create a parameter, and the type of this parameter here, as we can see, will be an array of numbers. Here we go. When I create helper functions, I like to log a message usually, just to have an idea of where the code is at when running. Cleaning timestamps. And let's call this function. So we can call it, instead of in main, we can call this directly in getData. So you see here, we have the timestamps in there. So maybe we can call clean. Let's import it first. Import clean timestamps. And maybe we can call it directly here, like this. And so here we are retrieving the timestamps. We are passing them directly to clean timestamps, the function. and putting the result inside timestamps. In main, let's log just timestamps for now. So the result right now is undefined because our function here is not returning anything. Let's return timestamps just to make sure that this works. Okay, so that works. In main, we are calling getData. GetData is retrieving the data. It's also calling clean timestamps to have our timestamps. And then they are retrieved over here and logged. That's the data flow right now. Let's clean our timestamps. We can create a new variable in our clean timestamps function, cleaned timestamps. And what we can do, since timestamps is an array of number, we can map over it. The map method allows you to transform the items in the list. So here we can use an arrow function like this, and we can say, hey, for each timestamp, do this. Create a new date and pass the timestamp multiplied by 100, by 1000, because timestamps are in seconds right now. We need them to be in milliseconds in TypeScript. This is how I want you to transfer them. And now, instead of returning the timestamps, we want to return the cleaned timestamps. Here we go. It worked. You can see that now, instead of timestamps, we have dates. Beautiful. The timestamps being logged in main are now dates. This is great. Now, we have two arrays, right? We have our timestamps and our values. And the first date is matching the first value. The second date is matching the second value. This is not very convenient. As we've seen in previous lessons, it's way easier to work with array of objects. So we need to restructure our data. Let's create a new function again, a new helper function, and let's call that restructure data.yes. We can export the default function restructure data. Here we go. And our restructured data will grab the two arrays. So we have our timestamps. Our timestamps now are an array of dates, and we have our values, which is a number, an array with numbers. Let's do a little console log, restructuring data like this. And let's call this in here. Restructure data. So the first parameter is timestamps, and the second parameter is values. Right? So I'm importing it. So VS Code just suggested it to me, so I pressed enter and it added the line at the top. And so this is how we want to restructure our data, and maybe we can put the clean data inside a variable called daily stock data, like this. And we can, this will be an array of objects, right? This is what we want. So we can use console table. So if we save this, right now, daily stock data is undefined. We are not doing anything in there. We need to work on it. All right, so we have our timestamps, we have our values. The first thing that we could do is to create a daily stock data array where we will put the restructured data. If you remember, timestamps and values, they have exactly the same number of items. The first item in timestamps is supposed to match the first item in values. So maybe we can use a loop to do that. If we create a new loop with I starting at 0, the index 0, and as long as I is smaller than the number of items in timestamps, which is the same thing, the same number of items in values, and if we increment I by 1, well, let's log this just so we have a look. So you can see that the loop is looping over all of the indexes. We can use this index I here now, this number, to actually retrieve the date in the timestamps array. And we can also retrieve the value at the same index in the values array. So now if we log date and value, we have the matching dates and values. We can push this inside our daily stock data array as an object. This is still returning undefined because I'm not returning anything in the function. So if we return daily stock data now, woo, it works. We have our table. It's very long because we have 11,000 rows of data. Maybe here we can use a slice to just show the first 10. Slice is a method on arrays. You give a starting index, a stopping index, and it will create a copy of the array with just these items in it. So now I'm seeing the first 10 elements in our daily stock data. We have an array of objects. It's way easier to work with this. If you are wondering about the data flow, let me start again. We have the get data function, right? So the get data function, if I press command and click on it, it will bring me directly to the function. So get data needs a symbol. The symbol here is Apple. We go in there. We check if we already have data for Apple in cache. If we do, we read the data from the cache. If we don't, we fetch the data and write it to our cache. Then we retrieve our timestamps. We clean them. The clean function just converts the timestamps that are in seconds to milliseconds, and then it converts them to dates. We retrieve our values. They don't need to be cleaned. And get data returns an object with our timestamps array and our values array, which are retrieved over here. Then we pass timestamps and values to our function restructure data. Restructure data creates a loop, retrieves each date and matching value, push them as an object in our daily stock data variable array, which is returned and retrieved over here. And finally, we just log as a table the first 10 elements. This is working pretty well. We have our data well structured. Now, we are restructuring the data, and that's great, but to know how much we're losing or gaining every day, we also need the percentage daily change. So here on top of date and value, what we would like to have as well would be the percentage change every day. So what we can do in our loop in restructure data is not only grab the value for the index that we are working on, but also the previous value. And to get the previous value, it's quite easy. We can do I minus 1, right? So this will help us retrieve the value of the day before, because all of the values are in a list. The list is ordered. So if we go to the previous index, we have the value of the previous day. Let's see. And if we want to compute the daily percentage change, we can use the value minus the previous value divided by the previous value. This is how we will know if, hey, am I gaining 2%? Am I losing 10% of my stock value? This will be the percentage change every day. And we can pass that to the object as well. So if we save this, so when you have a table layout like this, it just means that the length, the width of the table is greater than the width of your terminal. You can do a right click, toggle size to content width, or you can use the shortcut. I'm going to use the shortcut. Here we go. So now you see that we have everything that we want. I'm going to use Command B to hide the Explorer tab for now. And so you can see that now we have our date, our value. Oh, previous value undefined. Oh, percentage change, none, not a number. So we have a problem with the first row, but it looks like the other rows are okay, right? So it lost a little bit of value on the first day, on the second day as well, and then it gained a little bit on the third day. So it looks like everything works fine except the first row. And actually there's a reason for that, and it's quite logical. When we do the loop, we start with the first date and the first value. And we are asking our computer to find the value of the previous day. But it's the first day. There's no previous value. I is 0. And we are doing 0 minus 1. So it's looking for a value with an index of -1, which does not exist. So it's undefined. So previous value here is undefined. Then we are using undefined here to subtract. We're subtracting undefined to value, which is impossible. It's not, the result is not a number. So percentage change is not a number for the first date. We can easily fix that by overriding the percentage change for the first day. So here I'm grabbing the array after we looped through all of the elements. I'm grabbing the first row, the first item. I'm grabbing the percentage change and I'm saying, hey, I want to override it by 0, right? And that works in our case because on the first day, there's no percentage change, so it should be 0. So now that we have our percentage change, our daily percentage change, I think we are ready to calculate returns. We have our data, we have the daily stock prices with the value, we have the daily percentage change, so we can use that now to calculate returns. The idea would be to create another function with an initial amount of money, a starting date, the date of the investment, and then the daily stock data. And with these 3 parameters, we could calculate the returns. So let's do that. We can create another helper function. Let's call that getFinalAmount. GetFinalAmount.yes. So this function will calculate the returns and return the last, the final amount, the today's amount that you would have if you had invested in the past. So export default function get final amount. Here we go. And so to calculate the returns, we need a few things. We need the amount invested, which is a number, the start date, so the date of the investment, which needs to be a date, and finally our daily stock data. Our daily stock data is an array of objects, and if we check what we have in there, We have a date, a value, previous value, and a percentage change. We can see that as well here. So we can just grab that and use this type in our getFinalAmount function. We will use the date. We won't use the value and the previous value. We just need the date and the percentage change. Let's add a log as we did before. Console log, calculating final amount. And we can call this function. Let's do it, yeah, right here. Yeah. So the final amount will equal getFinalAmount. So VS Code knows that we have exported the function getFinalAmount, so it's suggesting to import it. We can press enter and it will import it for us. So the first parameter is an amount of money. So we can create a new variable here, amount. Let's say that we want to invest $1,000 in Apple amount. The second parameter is a start date. So const start date, we can create another variable for that. This needs to be a date. And let's say that we have invested $1,000 in Apple in January 1st, 2020. And finally, the last parameter, the last argument is the daily stock data. Here we go. We can log the final amount. So for now, this is undefined because we are not returning anything in our function. So the first thing that we want to do is to filter our daily stock data, because we don't need the data before the date of the investment. So we can use daily stock data. Since it's an array of objects, we can use filter, which is very handy, and we can create an arrow function. We can call an arrow function in there. So the parameter of the arrow function could be named daily data, since it's a day in the daily stock data. And we want to filter that with the date. And what we want is that the daily date needs to be greater or equal to the start date. Here we go. We can check. And now I'm filtering. We filtered over here. We put a copy of the array in filter daily stock data, and I'm logging it. And we can see that, yeah, the first date is January 2nd. Maybe the first January 1st was a holiday. I'm not sure, but our filtering works. And now we need to use the percentage change every day, the percentage change, and we need to apply that to our amount of money. Since we want to override to update the amount of money, we can create a new let variable, adjusted amount. At first, it equals the original amount invested, but then we can loop over the days, right? So here we are creating a for loop. We're saying, hey, in filter daily stock data, grab each item one by one and put them in a daily data variable that we're going to use. And so now, every day, we want to adjust the amount of money that we have. And to do that, we want to add to it the gains or losses. And we can have the gains or losses by multiplying the adjusted amount by the percentage change. So this here will be positive when the percentage change is positive. It will be negative when the percentage change is negative. So gains or losses, and we add this to adjusted amount. This here is a shorter way of writing this. We've seen that before, right? It's the same way of writing this. It's just that to avoid repetition, we can just use this shortcut with plus equal, and just adjusted amount will be overridden day after day. And finally, we can return this value, adjusted amount. Here we go. So it works. You can see that if we had invested $1,000 in Apple in January 2020, today this would have been worth $3,300. Pretty big gain. I have a different result than compared to the lesson because I did that, I wrote that a few days back, but everything is looking good now. It looks like our simulator is working. We can create another function maybe to log the results in a more interesting format. So we can create a new log results function, export default, log result. Here we go. And in there we could use the amount as a parameter. We can grab the symbol. This will be a string. Export, I forgot the function. Here we go. We could have the start date, which is a date. And finally the final amount, which is a number. And the job of this function will be just to log the results in a more interesting manner. We can use backticks, and we can write if you had invested. Here we can inject the amount of money. In here we can inject the company symbol on start date. I'm going to talk about start date in a minute. You would have, here we can have final amount today, right? We can use log result now instead of our console log. So log result, the amount, the symbol, the start date, and the final amount. I'm using this here, this pop-up here, to know exactly what I'm supposed to type, which is pretty nice. Okay, let's adjust everything. So I forgot a space here. If you had invested $1,000 in Apple on Tuesday, so right now the date is a very long string. We can format that. Something that you can do with dates. So the date right now is being converted as a string this way, but you can play with that. So we can say, hey, I want you to convert this date to a string with this specific format. So you can see that it's 2020 0101 T for the separator between the date and the time, and then the time. We can use the split method, which is available with strings, to split this in two. So this gives us an array with the date first and then the time. We are splitting on T. And since we just want the date, we can use the index 0 to grab the first item. Here we go. So now we have a more appropriate date here. And finally, we have the result here that could be rounded. So math.round, math, which is always globally available. Very nice. It works. We have the answer to our question. But everything looks good, but there's a problem. What happens if someone decides to invest money before the company was publicly traded? So for example, let's say that we try to invest $1,000 in 1950 in Apple. We don't have any error. We have an amount of money, but this here is not possible because Apple started being traded on stock markets in 1980. This is a problem. What we could do here is throw an error. So the code should throw an error if this date is before the company was publicly traded. It's fairly easy to do because we have timestamps here. The first item in the timestamp now is a date. You can see the type here. And the first date is when the company started being publicly traded. So we can use a condition and we can say if the start date, the date of the investment, is smaller, earlier than the timestamp's first value, so the first date in the data, the stock price data, if it's the case, I want to throw a new error. This is how you do it. And we can write a message. The company, I'm just going to reuse the message in the example. The company was not public at that time. Please choose a later date. And so if we run this code, you'll see that now we have an error. An error is being thrown at us because in our example here, the date here is earlier than the first data point, the first stock price for Apple. Errors are very useful to stop a script and give a message to the user explaining what is going on and what the user can do to avoid the error or explain the limitation of the script. So this is how you throw error. Very, very useful. And that's way better. If now we go back to 2020, we don't have the error, everything works as expected. But if we do another 1970, for example, we have the error, our script is not returning impossible values like it did before. This is better. And that's it. It was a big project. Let me just fix the code so we don't end this tutorial on an error. But congrats. We created a stock market simulator. We fetched data, we cached it, we restructured the data, we cleaned it, and then we computed the final amount after a few years of being invested in a publicly traded company. If you want, you can play with different companies, go on the Yahoo Finance website, test different companies, test different amount of money, test different dates, and if you want to push further, here are a few ideas for you. You can compare the returns for multiple companies. You can change the code to invest in multiple companies at once. You can buy and sell shares at different dates. This should be quite challenging and interesting. This is how we learn by pushing ourselves further. If you enjoyed the tutorial, subscribe to the newsletter, to the YouTube channel. You can also add a star to the GitHub repository, and I will see you in another video.